In AI systems, GDPR rights are more than legal promises. They become design requirements. Finding data, exporting it, correcting it, deleting it, limiting use, and honoring objections across pipelines, models, logs, and connected systems. So far, we've built the compliance foundation: inventories, data flows, AI risk, HIPAA safeguards, and GDPR applicability. Now we move from whether GDPR applies to how AI systems actually support individual rights. Each GDPR right should be treated as a system requirement, not just a customer service task. An access request means finding personal data across applications, storage, prompts, model inputs, and outputs. Requests to export, correct, restrict, or delete require workflows, controls, and evidence. The hard part is linkage, connecting identity to records and decisions, so teams can respond accurately, consistently, and prove what happened. Before you can honor access, deletion, or objection rights, you need a reliable map of where personal data travels. In AI systems, data may begin as raw records, then become training data, features, embeddings, prompts, outputs, logs, and decision evidence. Copies can also appear in caches, monitoring tools, analytics platforms, support tickets, and processor systems. The goal is lineage, knowing what was collected, how it changed, where it went, and when it should be retained or removed. For an AI access request, exporting a user profile is only the starting point. Teams need a controlled search across every place personal data may appear: core databases, CRM records, prompts, outputs, decisions, metadata, and audit trails. The response should include plain language context about purposes, categories, recipients, retention, and sources. Before delivery, review for third-party data, security risks, and confidential model details, and keep evidence of verification, scope, redactions, and delivery. Data portability is not a full dump of everything an AI system knows. Under GDPR, it usually focuses on personal data the user provided, such as profile details, submitted content, preferences, and transaction history. Provide it in structured formats like JSON, CSV, XML, or an API package. AI inferences, risk scores, logs, and model metadata need separate review because they may require limitation or exclusion. The workflow also needs authentication, encryption, controlled transfer, and audit tracking. Correction begins with the authoritative record, not with every copy scattered across the stack. Once an error is validated, the updated value must propagate into feature stores, caches, vector indexes, analytics tables, and decision services. The key risk is stale data continuing to influence scores or recommendations after the source is fixed. Teams need dependency mapping, recomputation, where outcomes may change, and an audit trail showing what was corrected, when, by whom, and where. Deletion is not just pressing delete in the main application. Start by verifying the requester and defining the scope. Then identify the systems in scope: profiles, logs, training sets, embeddings, caches, decision records, outputs, and processors. Before erasure, check lawful exceptions, such as legal holds or required security logs. Then execute the deletion, notify vendors, and keep evidence that each system completed the action. In AI systems, deletion may also require a retention strategy. Define retention periods for prompts, outputs, logs, embeddings, and decision records. At deletion time, decide whether the right action is immediate removal, suppression from active use, or expiration through backup life cycles. Legal holds and security investigations may pause deletion, but that pause must be documented. Also review training sets, fine-tuning data, and RAG indexes, and record any model remediation or compensating controls. Restriction is not deletion. It is a controlled pause on use while a dispute, objection, or legal review is unresolved. In AI environments, that pause must travel with the data. A restriction flag may apply to a person, a record, or a specific data element. Policy controls then block uses like training, inference, analytics, sharing, or automated decisions. The data can remain securely preserved, but downstream systems and processors must receive and honor the hold. Opt-out handling is more than a preference toggle. First, Capture the objection through a clear channel and connect it to the exact AI purpose, such as profiling, personalization, marketing, or risk scoring. Legal or privacy teams assess whether the objection is valid and whether overriding grounds exist. If not, engineering must disable or change that processing path. Finally, record the outcome, rationale, affected systems, and timestamp so the organization can prove compliance. Purpose limitation works like a routing system for data. Support chats, clinical records, and behavior signals are not raw fuel for any AI use that comes later. Each dataset should move only to uses that were specified, lawful, and authorized. If someone proposes model training, analytics, or profiling, compare it with the original notice, consent, contract, and assessment. Use dataset tags, access controls, and records to block incompatible reuse. Data minimization is one of the strongest privacy controls because it reduces risk before data reaches the model. Ask whether you truly need each field, identifier, log, or retention period. If not, remove it, mask it, aggregate it, or restrict access. This applies across the lifecycle: dataset approval, feature design, prompt logging, monitoring, and retraining. The less personal data an AI system holds, the less it can expose, misuse, or overlearn. Rights fulfillment becomes auditable when it operates as a process, not just a ticket queue. Each request needs a controlled path: intake, identity verification, classification, routing, fulfillment, and response. Privacy sets the rules, but engineering, security, legal, product, and vendors all need runbooks and evidence duties. Track what was searched, changed, escalated, denied, or completed. Then measure volume, cycle time, overdue items, exceptions, and affected systems, so the process can withstand audit scrutiny. The core lesson is this: GDPR rights only work when AI data is findable, traceable, and controllable. Build workflows for access, export, correction, deletion, restriction, and objection. Minimize data early, document every response, and use that evidence as the foundation for DPIAs, transparency, review, and transfer controls.